Hey guys, welcome back for another episode. First thing is I have to apologize because I've been slacking a little bit on content, but we're getting really busy. I actually have a bunch of stuff filmed. We just have to put some finishing touches on it, and we should have quite a bit of stuff coming your way shortly. Speaking of coming your way, I came up with an idea. I am looking to get more subscribers. So here's what I'm going to do. When we hit 500 subscribers, I am going to put all the subscribers' names into a random picking thing that they have online. And the winner is going to get a $250 prepaid Visa card. And along with that, probably a t shirt, a hat, whatever type of stuff that I have at the time that I will package up and send to you. We're trying to get the number of subscribers up, and this is the best way that I could think to do it. You don't have to purchase anything. You don't have to get credits. You don't have to do any of that stuff. All you have to do is subscribe, hit that button. If you want to get crazy, you can turn on your notifications, and we will try and get you guys some money. So, that being said, a couple of things that I wanted to go over on this episode. I'm in the process of installing a Terminator X stealth throttle body unit on this beautiful 1970 Mach 1 with a 351 Cleveland. Good friend of mine started out as a customer and wound up being really good friends really quick. His name is Richard Prizer, and I appreciate him trusting me with his beautiful equipment. This is one of 3 or 4 cars that I've worked on for Rich. Probably more like 5 or 6 if I had to guess. But I started messing around with fuel injection 4 or 5 years ago. And it was definitely a learning curve, especially for someone that in the racing world and street world has always been a carburetor guy. Never really got into this stuff. But now I love technology and I love staying up to date with the current stuff. And I'm probably still way far behind, but we're trying. So, one of the things that always confused me with wiring up fuel injection is inputs and outputs. And once the light bulb went off, I couldn't believe how easy it was to understand. I just, for some reason, had a little trouble wrapping my head around it. So, the whole reason why I'm making this video is if I could help one person understand it a little easier so that they didn't quite have to go through the learning curve that I did, I'll be happy with that, and that's good enough for me. So I'm getting ready to wire up electric coolant fans on this vehicle, and the output for the Terminator X is a ground. And that ground is going to have to trigger a relay because these fans generate more amperage, use more amperage to run than the grounding system that will come out of the Terminator X. And that's pretty much the case with all aftermarket ECUs and actually factory ECUs for that matter. So I'm going to include a wiring diagram that tells you what size wire that you should use for what amperage that you pull. As a matter of fact, I'm going to put a picture of it right about here. Hopefully I will anyway. And I'm also going to give you a relay diagram to show you how to properly wire up a relay. I'll put that right about here. And the pictures will also be in the description for the video. So inputs and outputs. I'm going to put this simple because it took simple for me to understand it. In order for, we'll use the coolant fans for example. In order for these coolant fans to know when to turn on, it needs input to the ECU to tell it. So in this particular case, the input is going to be the coolant temperature sensor. I'll be able to program that I want the coolant fan to turn on at, we'll say 180 degrees. And when the ECU sees the coolant temperature sensor at 180, it will send a negative trigger to the coolant fan relay, and that will activate the fan. And you could also tell the ECU to shut them off at 160 so that they're not running all the time when it's not needed. That's pretty simple. But so where I ran into the problem with understanding inputs and outputs was my own personal car. I have a Fuel Tech FT550 in it. That has a built-in delay box, throttle stop timer, shifter, all that good stuff. And I was trying to figure out how to wire it, and I called Fuel Tech, and their technical support is second to none as far as talking to people like me that know very little and should know more when using their equipment. They showed me how to wire up my trans brake button and everything, and that's the problem with just reading something and not really understanding it. They said, take this color input, put it to this side of the button, then this color output, put it to the trans brake solenoid. And I did what they said, but it still didn't really make sense to me. And then it dawned on me that in order for the ECU to put something out, it needs to see something to know when to put it out. So by putting the input on the trans brake button, when I push the trans brake button, the input is telling the ECU what's going on. And then when I let go of the trans brake button, for example, my shifter is on time. It shifts at 2.5 seconds after I let go of the trans brake button. So when that input, the ECU sees the input, then it sees it taking away, then the timer in the ECU starts counting, then it will send the output to the shifter solenoid, or in my case, an air MAC valve, and tell the vehicle when to shift. So it's, I did everything the way the wiring schematic said, and I don't know why it took me so long to wrap my head around input and output, probably because I was intimidated by what I was doing. And it was one of those, you're sitting on a couch at 10 o'clock at night, half asleep, and then it dawns on you. So like I said, I wanted to do this little video so that if it helps one other person, or they say, oh, that makes sense, that's really all I'm looking to do. I'm guessing 90% of you that know about this fuel injection and inputs and outputs are going to watch the video and go, no kidding, really. But like I said, I'm just trying to help the people that are maybe a little scared to get into it. Maybe this will give them a little push not to be intimidated. I am also going to do a quick description of relays and what they're used for. I have I'm going to get over to a whiteboard and I'm going to draw, and I'm going to be the first one to tell you I am not an artist. But again, if you're not really sure why you use a relay or how to properly wire a relay, I'm hoping that I can help you out with this, and it'll make life a little easier for you. Another thing to keep in mind is, now that we know what inputs and outputs are used for, one of the things that you're going to see when trying to pick an operating system for your vehicle, be it a Holley, Fuel Tech, Haltech, so on and so on, you'll know why you need the level that you need based on the inputs and outputs that are going to be required to run what you're looking for. For an example, when I first bought my Fuel Tech setup for my car, I was still running a carburetor. So I didn't have to worry about firing injectors, firing coil packs, stuff like that, which all eat up inputs and outputs. But luckily, I was smart enough to know that at some point I was going to want to put fuel injection on the car, and I wanted it to be, individual injector per cylinder type setup, port, or whatever you want to call it. So I purchased the FT550 because I knew that it had enough inputs and outputs to do what I was going to be looking to do in the future. Truth be told, I kind of wish I bought a 600, because now that I have the system on my car and running, I want to start looking into other stuff like shock travel sensors and stuff like that, which is going to continue to eat up inputs and outputs. So, on a shock travel sensor, that would eat up an input. So, if this helps you plan out a system and stop you from making a mistake of buying a system too small or possibly wiring a system differently, that's really all I'm looking to do. One thing you have to be very careful of is you have to figure out what polarity of output your system has. In my personal car, I have a bunch of different outputs, and the polarity can be changed, or they're naturally positive or naturally negative. So you have to keep that in mind. On this particular system, from what I've seen, all the outputs are ground. So you can't, when you go to wire up a relay, you can't hook it up to a certain side of the relay expecting to get power, and in reality it's grounding. That could turn into you having something wired incorrectly, and it could be a disaster as far as doing damage to the ECU. So on this particular setup, I'm going to take a fused wire from the battery, which I believe is going to be 12 gauge, because that's the type of wire I need for the amperage that the fan's going to pull. I'm going to go to the relay, out of the relay to the fan to ground. And then I'm also going to take fuse 12 volts and go to the 86 pin of the relay. And then the output from the Holly will go to the 85 pin of the relay. And that will supply the ground when I'm commanding the fans to come out. Again, I'll draw you a diagram. This is really easy stuff. And, if you follow it, you should be pretty good as far as wiring stuff up. Same applies for an air shifter for your car. Fuel pump, which this particular system already has a fuel pump fuse and relay built into it. I don't know if all systems come like that or not. You may have fuel pumps that pull more amperage than the system is set up for. If that's the case, the wire that they want you to run to the fuel pump, you will have to run to a relay. Now, in that particular case, that's going to be a positive output. So again, you're going to run battery power fused with the proper gauge wire to one side of the relay, and then from the other side of the relay to the fuel pump. Then the 85 pin is going to get a chassis ground, and the ECU fuel pump wiring is going to go to 86, which will close the magnetic gate and power up your fuel pump. So that's about it. I'm going to show you a couple of diagrams that I came up with. We're going to edit and wrap up this video. Don't forget, like, share, subscribe. Special thanks to Rich for trusting me with one of his beautiful cars. Appreciate that. We'll get some videos of this baby running. And tell your friends, let's get some subscriptions, and let's get someone $250 in their pocket. Thanks, guys. Okay, so on the left-hand side, you will see that it has the different amperages for what you could be wiring. On the bottom scale, it goes by distance. So the longer the wire is, the thicker it has to be able to carry the amperage. This is a pretty good scale, pretty easy to use, and all you have to do is figure out the amperage of the accessory that you're wiring, figure out roughly how long the wire is going to be, and you could go with the gauge that it recommends. It also doesn't hurt to maybe step it up one gauge if you're on the upper limit of amperage or the distance that you're running the wire. I wanted to include a picture of a relay to show how easy it is to wire. Pin number 30 will be your power source that you're going to use to power up your accessory. Make sure that that's fused as close to the battery or the junction that you're taking the power from. The wire coming off the 87 pin is going to go to the actual accessory that you're powering. On the left-hand side of your screen, pin 86 is going to be a power source from either your ECU, if it's a positive output, or jumping from number 30 over to 86 if your ECU puts out a negative output, which you would put to 85. So you have an electromagnetic gate inside the relay that swings closed, and that's what sends the power from pin 30 to pin 87. That electromagnetic gate is powered by 85 and 86. So, like I said, if you have a negative output, you're going to run the ECU wire to 85 and give 86 constant power. Or if you have a positive output, you're going to ground 85 and have the wire from the ECU going to 86.